Hi everyone, my name is Bello Abdulaziz and you are welcome to it.
Talk about current, voltage, resistance, how to connect batteries in series and parallel, and to like I discussed about that, if our battery is in series, the voltage is going to increase, but if it's in parallel, it's going to either be the same or it's going to reduce. So that last week was just a brief introduction to the world of electronics. So now, today, we're going to be discussing on some of the components, which is the what? Resistor and the LED. Just as we all know, if you want to cook food, maybe like want to cook jollof rice, you will need some spices, some ingredients to cook that amazing, delicious food. So that is the same thing for electronics. To build a complex or simple circuit, you have some kind of components. The components are the what? Are like the ingredients. So now, let's discuss about resistor. First of all, what is the resistor? As I said earlier, we have some basic concepts in the world of electronics. We have voltage, we have voltage, we have current, and we have resistance. Why I said it the last time that the voltage is the one pushing the stubborn electrons to work, that hey move. While the current is the one telling us the amount of electron that is doing the work per time. While resistance is the one that is trying to what? Slow down the electrons. Because as we all know, the electrons are like, oh, let me do my work and go and rest, Jare. So now the way that I want to do that work and go and rest, what are you going to be doing? I'm going to be moving too fast. And if I'm moving too fast, current can't do anything. Why? Current is going to tell you that, okay, Mr. Electronics, these electrons are moving very fast. That current is what? 2 amps. That current is 3 amps. That current is 4 amps. That current can be even be infinity. But what can they do? If there are a lot of electrons moving, it's going to lead to stampeding, just like if they're sharing food and jollof rice and people are rushing too much, it's going to lead to what? Stampeding. So now we now have something that is going to oppose the flow of the current. When it's going to oppose it, current is still going to move, but it's going to slow it down, like going to push it, wait, don't move. So now this resistance is a property. It is a property, but the main component doing the work is a what? Is a resistor. Is a resistor. So now, a resistor is a component in electronics that helps to limit or reduce the speed of current in a circuit to avoid the damage of electronics. Because if you can remember the last time when I decided to turn on a LED with a resistor and a LED without a resistor, we all discovered that the LED with the resistor was still on, but the one without the resistor did what? The thing blew, the thing went off. And that was because of what? That was because of the current moving through it was at infinity. What do I mean by infinity? Let's assume, okay, this is my power bank here. This is my power bank. This my power bank has the ability to supply a maximum current of 2 amps. 2 amps. Now imagine I just take my light, which is LED. As for now, I'm going to call it LED, not light, because that is the main standard term, LED. Now imagine I just take down my LED, connect it to my power bank. Before you know it, all the electrons will just move very fast and will do what? Damage the LED. So that is going to cause what? Infinity what? Movement of electrons. And it has a formula. I'm going to come back to that formula later. So now, for a resistor, if you look at the symbol, this is the symbol of a resistor. In a circuit, if some designers, if some people are designing that circuit, it is either they put the sign of the component there or they write the name. For instance, now, please give me some seconds. For instance, in a circuit, let's assume that I'm the one designing a circuit. Let's assume I'm the one designing a circuit and I placed a resistor here. After placing the resistor there, because I'm the one designing the circuit, I have to remember that this is the place for resistor, this is the place for capacitor, and so on. I'm going to either use the sign of a resistor. This is the sign of a resistor. This, or we can write it as R. It's just a short form, like the R is coming from here. Resistor. If it's capacitor, capacitor is one letter C. If it is diode, D. They have a lot of what? They have a lot of names. But there are some components that the names of the components is it will even sound weird if you later discover that that is the symbol of the component or the name of the component. So for a resistor, we have this symbol. Now, this symbol is telling us something very important. If you look closely at the symbol of a resistor, look at the sign. If you look closely at the symbol of a resistor, you see that it's moving like this. First of all, it's moving like this. See, it's going like this. Then it started having this zigzag line. What is the meaning of this zigzag line? This zigzag line is trying to tell you that no matter how stubborn the electron is, it will surely collide. Let's assume the electron is moving very fast like this. Vroom. The moment you get to this place, because the road is no more smooth again, what's going to happen to it? It will start colliding, eating itself, eating itself, eating itself, eating itself. Before that time, the time it's going to use to eat itself totally here is going to cause the speed. The speed to do what? To reduce. One perfect example for this is, now imagine you are using Nigerian road to go to a party, and you are using, let me say, like a smooth American road to go to a party. Now let's assume that you are going to the party. Let's assume you are going to the party on that smooth road. You don't even need to worry for anything. You don't be driving your car very fast. You don't be driving it very fast. If you are driving very fast, what's going to happen? You see that on a smooth road, a smooth what? A smooth road without any obstacle, what's going to happen? The speed is going to be fast. You just be moving, nothing to disturb you about press brake, press this, press that. But on a rough road, where the road is any small thing start eating your car, what's going to happen to you? And what's going to happen to you? You're going to discover that what? You're going to discover that the speed is going to be what? The speed is going to be slow. The speed is going to be slow. But this one moving fast will get to the party. This one moving slow also is going to do what? It's also going to also get to the party. But the only thing that's going to be different is the what? The time. This one will be faster. This one will be slower. So that is what a resistor is doing. A resistor is just to make sure that everything is working according in a circuit. It's trying to protect our what? Our electronics. That is what a resistor is. And we have different type of resistor. Like now, this is a resistor here. This is a resistor. And the function of a resistor is to what? Limit or reduce the speed of current in a circuit. And from the main symbol itself, this is how it is. As you can see, let's assume the electron is moving, to be moving very fast. Then once it gets to this point, this zigzag, it looks like a rough road. It's going to be moving very slow, and to now start going back straight. So that is why the symbol of a resistor is like that. And I have another example that, let's assume you are going to a party on a smooth road and to a party with a rough road. The one going to the party to a smooth road is going to reach there very fast. Now don't go to the party with a what? Rough road. But although two of them are going to reach the same party, but one is going to reach there faster than the other. So that is how a resistor is. And I said that the symbol of a resistor is ohms. This is the symbol here, ohms. And I said that if they are designing circuit, either if don't to if this place, if a particular point is for a resistor, it's either they will use this sign to notify that this is a resistor here, or they label it as what? R. So that is the same. And we have some type of resistor. We have the variable resistor. This is the sign of a variable resistor. And the variable resistor is like a resistor that have different type of resistance. That means you can adjust the resistance of a variable resistor to between 1 and the maximum resistance it has. And I also said about a what? LDR, which is light dependent resistor. And I said that an LDR is like a resistor also. But this type of resistor depends on intensity of light, depends on sunlight. That means when light should hit it, let's say like sunlight or your torchlight or anything, when it should hit a LDR, the resistance is going to reduce. That means when the light is high, the resistance is going to become low. But if you remove the light away, the resistance is going to become what? High back. Okay, if you cannot see, let me draw something like this. An LDR is something like this. It's now have a zigzag line inside. This is how an LDR. These are the pins. Pin. And as I said earlier, a resistor does not have polarity. A resistor does not have positive, it does not have negative. You can use it anyway. Like now, this is a resistor. This is a resistor here. As you can see, it has two pins. I can use here as my I can use it anyhow. So that is how a resistor is. It does not have polarity. So, and I said that this LDR is what is used in all these solar street lights. That means when there is sun, light is going to automatically turn off by itself. And when there is no sun, light is going to automatically turn on by itself. Maybe one day during our class, I'm going to build it also, and I'm going to explain the secret behind it. It's just some little component that was used. So that was what I discussed about. That we have LDR, we have variable resistor, we have a linear resistor. And the meaning of this symbol, the meaning of this symbol is that the thing depends on light. This thing depends on light. Sometimes we can also call it photoresistor. It depends on what? Depends on light. But assuming something like this, it means that light is going out. That's the meaning of this sign. This something like it means that light is going out. But if it's something like this, it means that light is coming inside. As because of we'll also be discussing on something like this also.